Hello everyone, welcome to the sixth lecture of this course. And in today's lecture, we are going to learn about doing data visualization in Julia. So before I start, I just want to show you one resource. This is a video from JuliaCon, which is the annual Julia conference from JuliaCon 2019. And here the video is about multiple dispatch. So this video titled The Unreasonable Effectiveness of Multiple Dispatch by Stephen Karpinski, who is one of the founding authors of Julia. And this video is actually showcasing all the effectiveness and all the features that multiple dispatch offers us. So for those who are interested about more advanced stuff, I will request you guys to follow this video and I will share the link of this in the resource section of the course page. Okay. So with that out of the way, let us start learning about data visualization in Julia. So there is one very nice discussion on Julia Discourse, which is the official channel for discussing about Julia and Julia related problems. Here, there is a nice summary of all the plotting packages that Julia has, and you can see that it has many. The first one is Plots.jl, then it has Maki, sorry, Algebra of Graphics, then Gadfly, Vega and Vega Lite is also there, Plotly Lite, then VGF plots X, Unicode plots, Gaston, GMP, GNU plots. So these many packages are available with Julia for doing data visualization. So in this course, we will only learn about plots.jl because this is the mostly used package. So if time permits, towards the later section, I will also try to cover about Maki. Maki is no doubt more powerful than plots.jl, but this first package is more matured, where Maki is still a package in development. So with that out of the way, let us start using plots.jl. So this is the GitHub page of plots.jl, and you can see that this is also a very actively developing package, and you can use this in your Pluto notebook with the command using plots. And what this will do, this will install the plots.jl package to your notebook. So this is a large package. So first time you run this command, this might take you some time to do all the installations and compilations. So I have run this cell, and let us wait for some time for this to get completed. Okay, so this is done. For you who are doing this for the first time, this will take much more time. This was fast for me because I have already installed this package, and most of the dependencies were already downloaded in my computer. So it reused all of those things, and it was already precompiled in my machine. So all of those things which usually takes time did not took much time for this case in for when I was running this in this notebook. But when you are running it for the first time, this will be quite a long process. This will take up to 2-3 minutes. Okay, so don't get panicked that it is not working. This will work for the first time. You just have to wait for some time. So now this plots package gives us access to a command or function called plot, and you will see that this is a function which has 4 methods available to it. So with this function, we can plot data. So suppose we have one array, 1, 2, 3, and 4, and we have another array y, which is 1, 4, 9, and 16. Suppose this is our data points. We want to plot it. So the syntax is plot x, then y. If you do it, you will see that your data has been plotted. So this is 1 1, this is 2 4, this is 3 9, and this is 4 16. You can verify the coordinates that this has plotted correctly. So these plots will automatically get embedded into your Pluto notebook. But if you are doing this in the REPL or if you are running this in a file, then you specifically have to tell Julia to display these plots. So you have to use this display command. When you are not using notebooks. Okay. So since you are not using notebooks, you will not see this in action. So now this plot is too big for my window. I cannot see much code. So let me quickly do one hack, which will define the size of this graphics. So let us do a 300 by 200 pixel plot. So what this command is doing will be discussed later. So those who are following along this tutorial, just run this and it will make your plots a bit smaller. Okay, so now let me rerun everything and you will see that our plots has become smaller. So this is a very basic way of doing plots. So now there are lots of things that you can do with these plots. You can change the color, you can change the thickness, you can plot different type of data, you can change the label, you can add a title, you can do multiple plots in one figure, you can add these labels here which are not shown here. You can choose different color schemes. You can change the colors of these data points. So there are themes for plots also where your plots can be tuned with a dark theme. So all of these things we can do, and I will try to show you guys as much as the options are possible to show in this 2 hour video. Okay, so let us get started. So first thing is, how can we change the color? So the first thing we might want to do is change the color. You can do it like this. You can just specify keyword arguments. So remember, we have learned about keyword arguments when we're doing functions. So you have to specify it like this: color equal. Suppose you want this to be red, you can write red, and you will see that our plot is now red. So you can specify color like this using names. So all names will not work. Suppose I am using a name like Scarlet, then this will give you an error that this color is not defined. So what it's doing is, so for now let me call it blue. So what this is doing is, this is looking at these colors. So there is a package called colors.jl. This is inbuilt to Julia, and this has defined all these colors by name. And when you are writing the colors within these quotes, you are actually writing these names. So suppose we have seen this example red. Suppose we want this color, say dark olive green, we can just copy it and we can pass this color, and you'll see that the color of our plot will change. So you can choose any color from here. Okay. Another thing that you can do, you can specify colors using hex value. So So what you have to do is you have to write within quotes this hash symbol. Then you can specify colors in RGB or RGB alpha format. So you can learn about this more here. So these are called text colors or web colors, and you can see how these are defined. What are the hex values of these colors? Those are also given. So you can choose any value from here. Say we want this maroon. So you can use this in your plot after this hash symbol. And if you run it, you will see that your plot has taken that color. Okay. So this is RGB format where the first two digits are representing the redness of the color, then the greenness of the color, and then the blueness of the color. And every two-digit pair here is actually representing a number from 0 to 255. So this is represented in number. Okay, as hexadecimal number. Okay, so what is RGBA then? You can add another two numbers. So A stands for alpha or opacity. Suppose you want to change the opacity of your plot, this line, you want to make it a bit transparent, so you can change these last two numbers. So here, this is RGBA format. So when you are using RGBA format, after the hash, you will be giving 8 letters, and the first three will be representing the RGB value, which is the color, and the last two will be representing the opacity. So here FF means truly opaque and 00 means completely transparent. So if you do 00, you will see our line has vanished because it is completely transparent. So to get a middle value, we can say example like 88. So you will see that this is still using the same color, but this is faded. So this is actually a transparent line. So you can use your colors like this. Now these colors can also be used like symbols. So what are symbols? In plots and in other Julia packages also, you will see sometimes that you are writing something with this colon syntax. Okay, so single colon, after that you will write a name. So colon red is actually equivalent to is specifying red in quotes. Okay, so if you do this, you will see that the color will change to red, and using the color like this is using the symbols. So here this colon red is a symbol. So you can again visit this page and you can choose steel blue, and you can use that as a symbol, and you see that the plot has taken the correct color. So you can probably get a idea that how much option you have with colors for plotting. So with that, let us see some other options. So suppose you want to change the thickness of this plot. So how can you do that? You can pass a keyword argument line width and say make it 1, which is the default. So you will see that the line thickness is not changing. But if you make it 10, you will see that the line is very thick. So probably 2. You can also abbreviate this line with keyword macro with LW. So line width is same as LW. So this is a shorthand notation. So you can check. Suppose this color is green now, and let us make it 4 so that we can see the change visibly, and you can see that the line width has changed. So when you are specifying colors like this, all the colors will be opaque. And now if you want to make them transparent, you can specify the alpha, which is again specifying these two last digits in RGB format. But when you are specifying it with the alpha keyword, then you have to specify a number from 0 to 1. Sorry, this is a closed range. And here 0 means this will be completely transparent, 1 means completely opaque. So 1 is the default value. If we pass 0.5, so this will be 50% transparent. So let me use the equiv symbol here. So line width is equivalent to LW. Here also let me use the equiv symbol. Okay. So now we have seen how you can do a simple line plot. So let me make a section here that we are doing line plots and some options. Okay. So suppose you do not want to show a line plot. Your data is discrete. You want to plot it as different points. So those are called scatter plots. So let me make a section for scatter plots also. So how can you do scatter plots? Let us start from here. You can do it in two ways. The first way is to specify a series type keyword and call it scatter. It will work if you type the keyword correctly. So you will see that now our data is plotted with markers, these circle markers, and this is called a scatter plot. Now, just to make it look a bit better, I will change this. So I will do 1 to 10 in intervals of 0.25, and everything will give you an error because the size of x and size of y is not matching. So this is another thing to note. When plotting x and y, the size of x and y has to match. So there are other cool things that you can do with matrices and other type of arrays. So if you have a 3D array and if you have a 2D um, X value and Y is a 3D array, then it will do a stack plot, those kind of things. Those are advanced things. We will not touch those in this video. So just think about 1D data that we are plotting, and when we are doing that, your length of the X array and the length of the Y array has to match exactly. Okay, so we can now modify this Y as X square. That's what we are plotting. So let me run that, and you will see that our plot has become very smooth. And let us go to the end, and you will see that this is plotting all the points with these circle markers. So what kind of customization do we have here? We can specify the marker size. Say we want to make it 10. You will see that this will become very big. Let us do it 1, and you will see that this will be comparatively smaller. So I think 2 is a nice size. Now we can also simply specify the marker. You can specify the markers like this, or square, or diamond. Let me increase the size a bit, say 5. So you can specify what kind of marker it will use using these symbols. You can also write them as strings. Sorry, you cannot write them as strings. So when you are doing these scatter plots, this series type can also be specified as symbol. Another thing that one can do is, rather than calling the plot function, we can directly call the scatter function. Then we don't have to specify this line width and the series type, and you see that this is giving us the same result. So this scatter function can also take marker as an keyword argument. So let me delete these cells. Okay. So far we have seen how to do scatter plots, how to do normal line plots, how to change some aspects of the plot itself, do some customization with colors and those things. So now let us look at some other figure customization. So here we will see how we can add labels and legends, which is showing y1 here. Suppose we want to write that this is a square function. So how we can specify those. So let us start from here again and change the color. Let's say to magenta. So if you want to add a X label, you can do it using the X label keyword. Okay. So here, this is our X. Similarly, Y label can be passed using the Y label keyword. So this will be X squared, and this label can be passed using the label keyword. If you run it, you will see that everything is showing correctly. Now, suppose you want to add title to your plot, you can also do that with the title keyword. Okay. So here you are seeing that the font size of everything is pretty large. So you can reduce that also. Okay. So now let us see how we can plot multiple things on the same axis. So here this whole white thing is called a figure. Then this x and y axis where the plot is happening is called the axis. This is our plot. This is a legend. This is Y level, X level. This is title. These are axis, not axis. These are tick labels. These are ticks. So with this package, you can modify and customize each of these elements. So we'll not probably go into all of those details and all of those um, minute customizations, but I will show you some other options. So suppose now we are trying to plot x square and x cube also. So how can we do that? There are multiple ways to do. The first thing that you can do is you can pass a array here. Okay. So this will work when the x value is same for both of these y value. So suppose we want to plot x as well as square of x. So you will see that this is plotting both the functions. We can also plot cube of x. So you will see this is plotting all the things in the same plot. Now, for the sake of correctness, I will remove the x plot and I also remove all the customization. So here, this is x square and this is x cube. We can do this separately also. So let me do it within the begin and end block. So after plotting x and x, we can also use the plot command again and then do plot x square with x. So you will see that this will not work because every plot command will create a new plot. So there is a special syntax or another method which we will use to specify that we want to plot everything on the same axis. So let me run this, and you will see that the first plot is not visible because this command is running last, and it has created a new plot which is overwriting the first plot. So if you comment it out, you will see only the straight line is visible, which is the first plot. For completeness, let me just give it some color so that this is visible distinctly. So let us use red and gold, and you will see the last plot where this is red is being shown and this is hidden. So if you comment it out, you will see that the gold straight line is visible. So what do you have to do in order to plot both of them in the same plot? You have to use the plot function. So this is not exactly a syntax, but this is rather a design recommendation which is followed throughout all the Julia packages, that the functions which are modifying something, it can be an array or it can be a plot, in place has a suffix exclamation. So anytime you see in Julia a function which has the exclamation mark as the suffix, then that is telling that this function will modify a previous object. So here, this plot exclamation function will use the previous plot and this will modify that. So that's how we will plot two things in the same axis. So let us run it and you will see that both of them are plotted now. You can also do it like this. You can store this plot, say, with the variable line, and you can pass line when you are using this plot exclamation function. So this is helpful when you are doing two, three plots at the same time and you want to specify, yeah, on which axis something you are plotting next will go. So there you can specify these variables also. So this, for this example, this will be the same thing. Okay. So now we have seen how we can do multiple plots in the same axis. Now here is a intuitive question. Suppose you have these two x values in array and sign of that and cost of that in another array. If I run this command, what will happen? Do you think it will run or it will fail? I will give you a couple of seconds to think about. Okay, so let us run it and you will see this will give a error. Why? Because I have forgot a dot here. Now, if you run it, you will see there is a dimension mismatch. It is saying that the number of rows of each array must match 10, 9. Sorry, 10, 19. So here this is 10 and here this is 19. So what you can do is you can specify it like this. So instead of making it a 1 cross 2 matrix, so let me just plot this data, and you will see that this definition itself is wrong. But when you use this, this will give you a 1D array which are made of unit range. Okay, so then this sine and cos, both functions are acting on each element of this array, and you'll see both are being plotted at the same time. So you can these features of the plots package to plot multiple things at the same time. Now, this can be changed to other variables also. Suppose you want to define different levels for these two things. What you can do is you can write one level to be sine and another to be cos, and you will see that the label will also get updated. Now here, let me quickly check one thing. Yeah, I have talked about that. So let's make it a scatter plot. And you see that all the points have become uh, marked with these circles, and you cannot visually see what I have plotted. So to change that, we can make sure that the points are more dense. Now this is more or less visible. We can increase the density a bit, and you will see all the points now. So now what you can do, you can also give, okay, let me copy this and use it in a new cell. So you can also give marker size, and if you are following this, also have a shortcut that is ms, and you can specify the same marker size for both, or here also you can give an array and specify 2 comma 5 that will choose different marker size for the two different plots. Similarly, you can also choose the marker. Say one has circle and the other has, say, plus. Okay, I think plus is not defined. So let us do square for now. Yeah, okay. So I think plus was defined. Yeah, plus is defined. I actually misspelled circle here. Okay, so you can change the markers also separately. Same thing can also be done for color. So let us do red and gold. And here you cannot see it. So let me change it back to square. This will be square if you spell it correctly. Okay, so dial down the size a bit. Okay, so suppose you want to change some other things about this plot. You can see that here when you are specifying the color, only the face color of the marker is changing, the stroke color is not changing. If you want to do that, you have another keyword argument marker stroke color, and there also we can make it gray, and suppose blue. And you can see that this has become gray and blue. If it is not visible, you can also do marker stroke width and then say 2 and 5, and you can see that the stroke width is also changing. So all of these keyword arguments that I am writing, these are called attributes, and here is a rough list of all the attributes that are supported by this plots comment. Okay, so you will see that you can change the color of annotations, you can change field color, you can change grid, that's color, grid alpha, width of grid, style of grid. You can also change font colors, you can also change font family. Everything is possible. So there are plenty of options, but if you want to see something, if you want to check whether something is possible or not, you can go to the docs for this plots.jl package, and that will show you, that will redirect you to this page, and it will show you some examples. We will see these animations in the next video. And here on the left hand side, you can go to series attributes, and here you can check all the things that you can mention. So one common thing that you will see that all of these attributes have some aliases. So here, suppose we are changing the marker size, and you see that we can also use marker sizes, ms or m size as alias. So if we pass any one of these keyword arguments, it will show the same result. Okay, so on the plot it will have the same effect. Similarly, the marker stroke color also has multiple aliases. So these are all attributes for our plots. Similarly, sorry, these are attributes for our series. That means the line plot or scatter plot. And these are plot attributes. So plot attributes are your background color, the out color of the background outside your axis, then display type, what is your DPI, that means dots per inches. That means how detailed your plot will be. Similarly, your layout, title of the plot, title font color, title font family, font horizontal alignment, orientation, size. You can see all of these. You have these subplots are attributes also. So we haven't talked about subplots. We will do that later in this video. So then we will discuss about these subplot attributes. Similarly, we have axis attributes also. Okay. So you will also see that many things can be customized here. So I think you have gotten the idea that this is a very powerful package. So we don't need this. This was my practice notebook. Let us keep it open. So this is the home page. So there are many things that can be done with plots. I will not be able to cover all of it. So if you want to learn more, you can go with the tutorials. So this will show you some basic things, then some advanced things also. So the tutorial has many sections. You can go through them if you want to learn more about the options in plot. Okay, so let me close this out. We'll talk about layouts when you are making subplots. Now, let me quickly show you one thing. Suppose you are making your plots and you want to change the theme of whole of the plot. Okay, so that means suppose you are making a presentation which have a dark background and you will like your plots to also have a dark background. So you can do that with this plot themes package. So this was the early stages. This was a standalone package, but now it has been added inside the plots.jl package. So what you can do is you can just use this command and this will choose from all of these predefined themes. So you can get a glimpse of all the themes that are available. So let me show you how you can change the themes. Okay, so you can just use the function theme and then you can pass a symbol. So Juno is one of the available theme. If you change it, you will see that nothing is happening at the beginning. But if you plot something after changing the theme, you will see that everything has changed. The background color, the size. So these things have changed. Similarly, we can also check this DAO theme that will also change the look of your plot. So if you want, you can go through all these available themes. I like this theme personally. So let us close this. Let us also close this named colors and HTML colors. We will come to color schemes later. So let us use this theme. I think I copied the wrong theme. Okay, so let us use this dark theme for now. Okay, so we will see some other customization options and then we will move on to the next section where we will learn about the different backends and then we'll look at how to do subplots. Okay, so let's now plot all the things within begin and end, and let's define our variables afresh. So let us have x1, which will be say 0 to 4 pi. So in Julia, you can also access these symbols, and these are defined with the accurate value. So the step can be 0.1. Then we have one function which will be sin x, another function that will be cos x, and the third function that will be sin x times exponential minus x. Okay, so now let us plot all of them. So we can do it like this. We can do it like this because all of them are sharing the same independent variable. And if we plot it, you will see that everything is being plotted. So I'll quickly change the size once more. So it was done here. Yeah. So the size has changed now. So let us change it and let's make it up to 10 pi. Oh, that is too much. So maybe 6 pi. And let's make the damping small. Okay. Uh, maybe zero point 0.1. Okay, so these are three functions that are being plotted. So here I quickly will show you one technique. So you can use this X symbol and follow it with this dot, and then what you can do is you can write the same expression but without dots. Okay, so okay, sorry, the star should be there. Yeah, and now you will see that y3 and y4 are same. You can also check it like this. You see that this is true. So what this at the rate dot is doing, this is telling Julia that every function used after at dot will be broadcasted. So sometimes when you are doing multiple operations like this might be tedious to write dot everywhere. You can use this syntax, which will just tell the code that every function that you encounter, so this function, this multiplication function, this exponential, then again this multiplication, everything has to be broadcasted over each of the element of x1. So let me delete this and let me call it y3. And something has changed. What? Okay, y4 is not defined. Okay, so okay, so now let us customize our plot. What we can do, we can store this in a variable and we can use this plot exclamation function to work on this plot. So suppose we want to change the x level, then we can make it x, and y level we can make it something like several functions. Then you will see that this is still working. Now suppose we want to change the font size. What you can do is you can go to this attributes section and you can search for font size. So this will be either in access attributes or in plot attributes. Yeah, so this guide font size, which is under access attributes, will fix the font size of your access guides. So you can see that this has a alias of level font size. So what you can do is you can pass this keyword argument and change it, and you will see that your font size has changed. Similarly, you can also change the font size of these ticks, and we are also going to make it 8. So all the font size are now same. So I think you have noticed a nice capability of Plots.jl here. So you can call the plot function without giving x, y, these arguments. You can just call it with these attributes. And if you are using this exclamation version of the plot function, then it will work on the previous element and just change this attribute that we have passed. So what will happen if we remove the exclamation? This will make a new plot. Okay. So we don't want that. We can even specify p here to be extra safe, and this is working. So another thing that you can do is for some attributes, you can change them by their own functions. Okay. So this X level attribute, you can change it using this function X level exclamation like this. And you will see that it will still work on the previous plot. If you do not give the exclamation, then you will see that it is giving an error, then this function is not defined. So it is not necessary that all of the functions will have this normal method and this exclamation method. Some functions have only this exclamation method defined, some have both defined. Okay. So suppose if you want to change these labels and those things, you can use this named function also. Similarly, you can fix the limits also. 0 to 10, and you will see that we are cutting off something. So 6 pi will be almost 20. So let us do 20, and you will see that now the limit has changed. You can also do this at different location. So the last call that you have made will take effect. So if you remove this, you will see that our x limit is 0 to 5 as we have defined here. And if you uncomment this, it will be 0 to 20. So let us define the while loop here. So let this be minus 1.5 to 1.5. Okay, so this is again some features. Similarly, you can also change the title. You will see again that the font size is too much. You can change it like this: title font size, and make it slightly greater than 8. So you will see that this has changed. I think you also have, so let us check in plot attributes. So you can use this font family attribute to define different kind of fonts. So let me quickly go over them. Okay, so let me try this out. Suppose I want to change this example plot writing to a different font. We can do that using title font family, and let's see if Times New Roman works. You will see that it has changed. So if I uncomment this, so to see the change perfectly, let me do it like this. You can see that the font family is changing. You can also specify sans serif to use serif fonts, sans serif fonts, serif to use serif fonts. Okay, so you can customize your plot like this, and you can also change the color. So suppose we don't want it to be white, we can make it say gray 2. Gray 2 is dark, say gray 9, or maybe we can make it light gray. So we can change the color of the font also. So you can see you have image customization option. So now suppose we want to change the labels, we can do it here. We can write sin x, cos x, and damp sin. So this will change the legend, and in order to change how the legend look like, we can either specify like this. So legend false, we remove the legend together. You can pass false also. True will let the plot choose a location by its own logic. So we can override that by giving it specific location, say upper left. Sorry, this will be top left, and this will go to the top left part. Okay, you can also specify the legends to be at outer location. So outer bottom, we'll put the legend outside this plot in the bottom. You can also search here. So this will be plot attributes. So legend column is one of the attributes. So if you pass it and make it 3, then you will see that this has the legend is now presented in 3 columns. So we can also pass legend font size and make it smaller, say 4, and you will see that this will become smaller. So all of these tweaks are available. So with that, I think we have talked a lot about plots, how to customize them. Now, in the next section, we will see different kinds of plots. For example, we will see bar plots, histograms, etc. Okay. So far we have only seen this line plot and scatter plot, but I want to introduce you to other kinds of plots also. And all of this customization technique will work on them. So before showing you different kinds of plots, let me also talk about color schemes. So we have seen that when we are plotting something, we can give it desired colors. So red, green, blue. So this will take that color. But even if we are not defining any color, in that case also, it is assigning some colors by its own. So this is coming from a predefined color scheme, and you can change that also in Julia. So you can go to the docs of this Plots.jl, and you will find these color scheme pages, which will say that this package supports all color schemes from this color scheme.jl package, and you can open it and you can learn about it, how different color schemes are defined inside this package. So what essentially you can do is, so these are all the options available. You can see how many options are available here. So what you can do to specify any of these color schemes is, suppose we want to do this blue 8, we have to specify one option when we are plotting our function. So we have to pass the name of the color scheme with this colon syntax. Okay. If we run the code, you will see that the color has changed. So let us choose another color scheme so that it can be easily visible. Let us choose this one. You will see that the colors have again changed. Now, I like this color scheme particularly. Okay. You can also use this one. But you will see that when you are choosing any color scheme, all the colors are not different. That is because these color schemes have many colors defined and the colors will be very close to each other. So what you can do is you can choose a smaller theme, maybe this heat one, and if you run, you will see that the colors are different now. So you have all these options. So if your data points are discrete, if you are plotting some categorical data, you can use these palettes which have a smaller number of colors available. And if you have continuous data, you can also use these palettes which have the colors defined in a smooth way. Okay, so we can also check this. You see that the colors are somewhat different. And okay, so we can specify the color scheme like this. Let us check another one. So you can see that the colors are changing. Now, when you are specifying the color scheme here with this palette option, this will only work for this particular plot. If you are doing another plot, then this will again choose from the default value that has been defined. Okay, so you can do another thing, that is when you are choosing the theme function, then after providing the name of the theme, you can also specify the default palette. So our palette will be this. Let us choose one color scheme. Let us do this. So this will be our default. Now let me just run this command. Just so the plot size is kept same. So you can see after running that, if we run this cell, it will not change anything because we are specifically saying to use this color scheme. What you can do is you can just comment this out, and then if we change, then if we run, you will see that the color has also changed. Again, to check with another color scheme, we can choose something from here. So let us do this one. So let us change it here, run this, and when we run this cell, you will see that the colors are also changing like this. Okay, so that's how we can use different color schemes within our plot. So we can close this and close this also. We can close this link also. Okay, so now let us move on and learn about different kinds of plots that we can do. So far we have learned about line plots and scatter plots. So this plots.jl package, this supports many other kinds of plots. One is bar plot. So I will show you an example. So suppose we are plotting this. So this is just plotting random values. You can just check with this. Every time we run it, this will give us some random value. So we can do one thing. We can specify the series type to be bar, and now the values will be plotted in a bar plot. So you can either do this, or you can use the bar function itself. And let us change the palette to muted. And what is the problem? Okay, I have chosen a name that is not defined, so let us use captain only. Okay, so you will see that this is also working. Similarly, we can also plot horizontal bars by passing the orientation to be horizontal, and we can see that this is plotting the bars horizontally. Now, to better see it, you can also pass the x-limbs to be 0 to 1.5. And now you will see that every time we plot it, the bars will be different because we are using a random function. Okay. Now let us see histogram plots. Okay. So we can do that using the histogram method. So what this does is get a set of values. Say our values are 1 to 1000, and using these values, this will plot a histogram. So you can check the live docs for the methods. So it takes one vector and it takes another argument called beans. So the beans is actually defining in how many bean we want to divide the sample space. So if this is our input and if we are dividing it in 50 beans, okay, sorry, this is a positional argument. Okay, we have to write it like this, and then you will see this is our histogram. So since we are choosing a unit range, this will be a uniform distribution. So here you can specify another option, that is this normalized keyword argument, which will make sure that your histogram is normalized. You will see this will change the Y scale in such a way that the area under this histogram is 1 now. Okay, so this is not something interesting. So let us plot histogram on this random function. Okay, so if we do rand 100, then it will give us random numbers in an array of length 100. So let us do this. and I have an extra parenthesis, and you will see that this is the distribution of the random numbers that has been generated. Okay, so you will see that the distribution changes if we run it multiple times, but if we increase the number of elements, then you will see that the distribution is more or less uniform because this rand function is actually generating random elements from a uniform distribution. Okay, so I think it is written in the doc somewhere. So similarly, we also have this rand in function, which will generate a normally distributed random number. Okay, so which will generate an array of normally distributed random numbers. So if we do this and change the color, you will see that the random numbers are normally distributed. If we run it, you will see the distribution is changing slightly, but if you increase the statistics, you will see that it is mostly remaining same. Okay, so the function is intelligent enough to choose between these field histograms or step histograms depending on the size of the data. Okay, so we can see that this is following a bell curve as expected. Similarly, we can also increase the statistics here and you will see that this is almost uniform. Let me increase the statistics more and you will see that it is a uniform distribution. So you can plot histogram with this plot function also by passing the series type. So if you go to series attributes and search for series type, you will get all of these types. So let me copy them and paste them here for your reference. So what you can do is just use the plot function and pass it a series type argument. So we can make it a histogram. Then this will be same. So let me change the color. So this will be similar to this, but we can also make it a scatter hist, and this will plot the data like this. We can also make it a bar hist, which will plot it like this. Step hist will plot it like this. And there are some other methods also. You can try them. Okay. So now let us see how we can plot contour plots. Okay, so in order to do contour plots, we have to define a function, 2D function. Okay, so let us define our function to be f, and this will take two arguments x and y, and it will return, say, x square plus y square. Okay, and now we want to plot a contour plot based on this function. So what we can do is we can do this inside a beginning block, and let's define our variable as x1, 1 to 10, x2, 1 to 10, and we can pass the values x, y, and the function that will be acting on these two variables in order to give us the value which will be used to do the contour plotting. Okay, so let us do that. And it is saying multiple definitions, so we can make it var 1 and var 2. This will be var 1, this will be var 2, and you will see that this is our contour plot. So the color here, this is signifying less value, and the color here is signifying higher value. So our range is 1 to 10. So the maximum value that this function will return will be 10 square plus 10 square. So this is going to be 200, and you can see that the maximum range is around 200. Similarly, here the lower value will be 1 plus 1, 2. So you can see if these gaps are 25, this will be around 2. Okay, you can pass another option here, which is field equal to true. That will fill the space between the contour plots. Okay, so you can do that. Similarly, you can check this also. So suppose these are from minus 10 to 10, then make it 3 and 4, and we don't need to define the function again. Then you will see that this is a symmetric case now. So this was also symmetric case, but the range we were looking at were not showing that symmetric nature. So here you will see that at 0, 0, this is lowest 0, and as it is increasing, this is also increasing. You can refer to the color bar to get the value. Here you have a nice example where you can use anonymous function. Okay, we have learned about anonymous functions in one of the previous videos. So you can see that here the third variable is actually taking the name of the function. So what you can do is, let me just pass 1 is to 10, 1 colon 10, and here let me make it an anonymous function which will take two parameters x and y, and that will return, say, x star y. Okay, and this will then again be a function like this. If you want to make it something interesting, you can make it a 2D Gaussian. So you can do it like this: exponential minus x square plus y square, and we have to choose the range carefully. So let's make it -10 to -10. So you will see that this is how the plot will look like. So we can reduce the range, and you will see that this is our function. So what you can do more is smooth it, and now you see that this looks like a nice Gaussian where the intensity here is maximum and it falls off nicely. Okay, so that's contour function, and similarly we can also do surface plots. Let me just copy paste this same function, and I will just change the contour word to surface, and you will see that you have a surface plot for this function. Okay, so these are again delving into the advanced territory where we can do 3D plots and stuff. So let me stop these different kinds of plots here. I just will talk about if you want to change the color scheme that this is using, you can specify that using color. So I can make it at 100, and you'll see that the color scheme has changed. Similarly, you can do it here also. You see that this has changed. Similarly, you have this levels keyword, which determines how many levels you want to have in this contour plot. So this each level is this each section, which are represented by different colors. So if you have 8 levels, you will see that 1, 2, 3, 4, 5, 6, 7, 8. We have 8 levels. If you want to make it much granular, you can do 80, or if you want to make sure this is small, you can do something like 5 also. Okay, but for this function, something like 25 is good. You can also specify the line style to be dash, then these lines will be dash, this can be dash dot or dot. Okay, so with that, let us conclude this section, and we'll move on to the next topic where we'll see how we can do subplots. So subplot means that if you will have one large figure, and in that figure you will have several plots. And let us see how we can do subplots. Okay, so let us begin by plotting a simple function, say for 0 to 4 pi. We want to plot the sine function. So this is giving our plot. Let's make it smoother, and now this is our plot. So if you want to plot two things in the same plot, we can also pass the functions like this, and we can also change the labels as sine and cos. So see, everything is plotted on the same axis here. Now, if we want to plot these two on the same figure but on different axes, say there will be one plot and there will be another axis, okay, and both of them will be on the same figure. So how can we do that? We can do this by simply specifying the layout keyword parameter. And if we say layout equal to, you will see that it has splitted the plots into two different axes, and it has also correctly assigned the labels also. So here 2 means actually 2, 1 comma 2. You can also do 2 comma 1, and that will generate the plots and stack them vertically. You can also see that colors and line width, these will also get propagated to these plots. Okay, you can also do it like this. So suppose we are plotting both of them, and we are plotting both of them separately. So here we'll only plot sine, we'll pass only one level, single color, and we will not pass this layout. So if we do another plot and save it in a variable p2, you will see that it is only showing the second plot here, but we can use the plot function again to pass all these plots in an array, and then we can specify the layout to be 1 comma 2, and so you have to do it without the parenthesis, and you will see that this is also working. So that's some way to do subplots. And I wanted to hide the legend. You actually have to write false if you want to hide it. Okay, so that's how we can do subplots. If you want to learn more about this, you can go to the layouts page in this docs of Julia plots, and you will have several examples. Okay, you can also do inset plots like this. So we will not see these things, but I will show you this layout macro and these 2 cos 2, as well as these different with subplots. Okay, so let us do this. So suppose you wanna do this plot, say 1 is to 100, and you will plot sine cos exponential and say log. Okay, you want to plot all 4 functions. So if you do it like this, you will see that everything is plotted in the same plot, and since this is exponential here, this will shoot up everything. So let me change it to some other function, say absolute, which will just plot x equal to x equal to absolute of x. Okay. So this absolute will just plot the same number because we are all using the integer, positive integers here. Okay. Now, if we want to make it into a 2 cos 2 grid, you can just specify 4 and it will automatically make it a 2 cos 2 grid. So let me smooth them out a bit, and you can see that it has divided all the 4 functions into 2 cos 2 grid, and it has plotted them separately. You can also do this, or this, where you are specifying the dimensions by hand. If you do this, it will create the layout perfectly, but since it has been given only 4 plots, it will plot them on the top 4 and the rest will be empty. Okay, so let us do this. Okay, now suppose I want to plot them in a 4 plus 1 manner, but I want to make sure that the plot, the cost plot, which is the second one, has greater height. So to do that, you can use the grid function. Okay, how can you use the grid function? So at layout, you will say that this is a grid, and this will take the dimension of how many rows, how many columns, and then you can also pass heights to it, and then it can take the heights of all of these plots. Okay, so suppose I want all of them to be 0.2, 0.2, 0.2, 0.2. Then, okay, so you have to make sure that the heights we have provided are adding up to 1. So let's just make the first one 0.4, then it will add up to 1, and you will see that the first plot is comparatively larger. So we wanted to make this cost plot larger originally, so you can do it like this: 0.1, you can make it 0.7, and the rest 0.1, and you will see that this is how this is looking. Again, clearly, this is not showing 70% because there are some other elements which are blocking. So we can also put legend equal to false, axis equal to false, and maybe we can also provide a size to it. We can make it a bit bigger. So let's make it 400 by 400. And now you will see that this is much larger compared to these three. Let's do 0.15, 0.15, 0.15. So this will be 0.55, and you will see that the sizes have changed accordingly. So that's one method, this grid method, that you can use to manually tell the proportions of all the subplots. Now suppose you are doing this in a horizontal way. So you are plotting everything in different columns. Will this work? You will see that this is not working. Why? Because we are making a horizontal grid, but we are specifying heights. So this will take the first height and this will plot everything in the first 15%. So we have to call this widths. And now you will see that it is working. Okay. Although the choice of my functions are very bad. So let me do 1 to 5. Yeah, now you can see all the plots. and again, and widths have been chosen as per the values that have been given. So we can make everything 0.25, and that will have all the plots taking up the same area. Okay, so that's how you can do simple subplots. We can also do these complex subplots like this, but this I will talk about in the next video when I am discussing more advanced things. Okay, so I think we are very close to the 2 hour mark. So what we can do is we can talk about backends used by Plots.jl. Okay, so what are backends? You can just search here and go to this page, and you will see this documentation here. So backends are the underlying method which the Plots.jl package is using to render the graphics. Okay, render the plot. So there are different backends that it has access to. The one which is default is this GR backend. It also have a Python plot backend, which is using matplotlib under the hood. It also have plotly.js, which has Gaston, inspect DR, Unicode plots, these kind of things. And they have provided a nice table. So if you want features, you can use either one of these. If you want speed, you can use either one of these. If you want interactivity, so suppose you want to click your data, you want to move your plots, then you can do plotly.js, that is the best. And the author also says that GR is his favorite for speed and plotly.js for interactivity. Okay, so you can look at this table and you can choose the backend that you want to use. So what this plots.jl package is doing is that it is taking all of these backends and their plotting methods, and it has combined everything in its functions. So if you are just calling the plot function, then under the hood, it has already defined and decided on which backend to use. If you are not specifying that, it will by default use the GR backend. You can change that also. So if you are when you are calling the plot function, it will just plot all the things that you wanted to plot using the GR backend. Similarly, if you are using plotly.js, it will use that backend to plot. So you don't have to do specific and different function calls for all of these packages. This package plots.jl is doing all the work for us. So here, the very first command that we wrote was gr, the size, and I told you that this will be discussed later. So this is specifying that we want to use the gr backend for our plots. We can change that also. So suppose we want to, let me annotate first that by default it will use gr backend. So suppose you want to use the plotly backend, you can just call plotly like this, and then you might get some errors because we have been using the gr backend throughout the whole code. So what you can do is you can try plotting something, and you will see that this is using the plotly backend. Okay, although this has given error, you can see that this is clearly different from this. Okay, here You can zoom in, you can save it as a PNG, you can hover over and get the values of these data. So let me increase the size. Say we want 600 by 400, and then let me plot it with more points, and you will see that this is our plot. And here you can see that you can hover over the data points, and this will give you annotation of the values. You can also go to plot list page from the plot. You can pan it, you can download it as a PNG. We'll look into that later. You can zoom in, you can zoom out, you can auto scale to fit everything. Okay. Similarly, if you are doing a 3D plot, say suppose we are doing -5 to 5, and let me define another anonymous function which will return x square plus y square, but with a negative sign. And we want this to be a surface plot. So you can see that this is our plot, and when you are using Plotly, you have this option to rotate this plot, zoom into this plot, so you can do things like this. So x lim to be -8 to 8. Similarly, y limbs to be -8 to 8. And you'll see that the change is getting reflected. Okay. Similarly, we can also do contour, and this will give us the option to zoom in, zoom out in the contour. So here you can also do fill equal to true. So you can also do levels equal to say 10 and color equal to after 10. We see that everything is working perfectly. So this is a very brief introduction to Plotly. You can use it if you want some interactivity in your plots, but the drawback is that this Plotly backend, they cannot save your plots in vector graphics, but when you're using the GR plots, it can save your plots in PNG, vector graphics, PDF, all of these things. So and Plotly can only save into PNGs. So we are at the last section of today's lecture. We have learned many things, but the most important thing is how to save your plots. So how can you do that? Let me save this in a variable. So to save plots, you have this save pic function where you can provide the my plot.png file name, and your plot will be. So we are running into an error that some package is not installed. So what we can do temporarily to check how you can set the plots. We can disable these plotly plots and let me run this GR backend command again so that we are changing the backend. Now let me plot something. Say wanna plot this thing. So this is the plot here. And if you run this command again, this will save it in this location. Okay. So you can open it in your browser. You can just copy paste the location and you will see that this is the plot that you have saved. It might be sometimes blurry. You can provide the DPI that it should use to save your plot. So you can specify the DPI, not here, but here where you are plotting. Now let me save it again and reload it, and you see that this is a plot in much higher resolution. Okay, so with that, let me conclude today's class. So we have covered many things. So let me just write them out. We have learned how to plot in Julia using the Plots.jl package. We have learned about different backends used by Plots.jl. So example is gr plotly. We have learned about line plots, scatter plots, histograms, bar plots, horizontal bar plots. We learned about contour surface plots. We have learned about customization of the plots. You can change color, line width, marker, size, the theme, color scheme, everything with this package. And these are called attributes. Whenever you are unsure of what these attributes are, you can refer to the documentation. We have also seen how to put labels, access labels, change font size, etc. We have also seen how to do subplots using different layouts. Lastly, we have seen how to save your plots. Okay, so let me quickly check if I have missed anything. No, I think I covered all the things that I wanted to cover. So in the next class, we will learn some more how to do animations, advanced layouts. Then we will also look at manipulating data. That means reading, saving, processing data, and that we can do with data frames package. So that will be the main focus of our next lecture. And after that, we'll do numerical computations. So we'll start with interpolations, differentiations, then we'll move on to integration. We will write all the codes in the beginning from scratch by our hand. Then we will see how there are some packages which can help you to do this kind of numerical computations. Okay, so that is the plan for the next two classes. I hope you have enjoyed today's class. This was a lot of information, so I will request you guys to go carefully through these lectures, and I will see you in the next video.